things they do, the things they say.
Hi, nice spring day, right? Then it's time to have a look at the scattered light and find also polarization effects.
Takes away those restless fears now that turn your blue skies into gray.
Well, the sky is blue and we don't want it to turn into gray. But we can understand why the sky is blue and then enjoy it twice from the beautiful sunset and sunrise. You can even enjoy it more than poets because now you will understand the why. So the sky is blue because of a scattering. Light coming from the sun is white, but it interacts with the molecules in the atmosphere. Nitrogen, oxygen, argon, and some dirt too that Homo sapiens have thrown up there by burning coal and gasoline. Light coming from the sun is white and unpolarized. That light interacts with those molecules, but the magnitude of the interaction is different depending on the wavelength of the light. Consider an incoming electromagnetic wave acting on a free electron of electric charge E. Then the differential equation for the motion of the electron is given by Newton's second law. That has a solution which depends on the inverse of the square of the frequency. Charges follow forced oscillations in phase with incoming wave. This creates an electric dipole of dipole moment P equals to E times R, where R is the displacement of the electron with respect to the equilibrium position, with a maximum momentum of E squared E naught over m omega squared. The emitted power of the electric dipole oscillating under these oscillations is given by. This is the power of the electric dipole radiated in Rayleigh scattering. Well, this expression is valid for free electrons, but if the electron is bound to an atom in a transparent medium, then the solution of the differential equation is where omega naught is the natural frequency of the electron in the atom or molecule, and omega is the frequency of the electromagnetic wave. This omega naught tends to be much larger than omega, so we can write that. So the scattering power is proportional to the fourth power of the frequency. So for blue light, that the frequency is larger, scattering is larger, and for red light, whose frequency is shorter, scattering is smaller. This would explain why the sky is blue, because blue light is scattered more than red light. This would also explain why sunsets are red in the direction of the sun, because most of the blue light has already been scattered and there is mostly red light left. Now, let's talk about polarization of the light in the sky. Light from the sun is white and unpolarized. Consider the sun, the earth, and you up here. If you look directly at the sun, which you shouldn't, only foolish people would do that, you would see that it comes unpolarized in all directions. We can describe it as polarized horizontally, represented by this dot as an arrow going in and out, and vertically represented with this double arrow. But if you look sideways to the sun, because of scattering, light makes the electrical charges to oscillate. Charges oscillating in the horizontal direction behave as a dipole and radiate in all of the directions, except in the direction they are oscillating. So you, down here, will see light polarized with that direction. For the other component, for light polarized vertically, as this double arrow, electrical charges will oscillate in this direction and radiate in all the directions except for this one. If this angle is 90 degrees, it will happen that this charge is not radiating towards you, so you won't see this direction of polarization. So light you will see will be partially polarized in the dot direction. And you can see this by using Polaroid sunglasses and looking for this direction with respect to the sun. Remember to never look directly at the sun, and may science be always with you.